So we've introduced a bunch of different quantifiers and a bunch of different notation, and this all seems very theoretical. So let's see if we can't bring this back into a little bit more of a computer sciencey realm by considering finite domains, which Rosen presents in section 1.4.4. So here, if the domain that you're talking about contains a finite number of different elements, then it's pretty easy to think about the different quantifiers in terms of simple for loops in your favorite programming language. So for example, if we had our domain being the integers 0, 1, 2, 3, all the way up to 9 right here, and our propositional function being our favorite example, x squared is greater than x right here, then we can actually determine the truth value of the quantifier statements simply by writing a short little program. So I can figure out if for every x, x squared is greater than x on that particular domain, there exists an x such that p of x, or there exists a unique x over here. So all I would have to do is I would have to simply write up my propositional function here, and you can see that the way that I've written it is such that it's going to return a value of true or false given a particular input x over here. And then after that, I go ahead and I define a couple of variables right here. And then all I have to do is loop over all the possible values of my domain. So here, my domain is simply 0 through 9, so I'm simply going to loop over all those different values, plug them into my propositional function, p of x right here, and keep track of when it's false, when it's not false, etc., etc. So I keep track of when it's true with a little counter right here. And then with this counter, I can then determine, well, if this counter of the truth value of this particular propositional function right here is equal to 1, that means on this domain, there was exactly one value in my domain that made it true. So that would mean this thing right here, this uniqueness quantifier, would be true. Otherwise, it's going to be false. Next, what I can do is I can see whether or not this universal quantifier is true. Because if my little truth counter here has the same value as the length of my domain, that means for every value of my variable in this domain, this propositional function right here is true, and this statement would be true. Otherwise, it's going to be false. And over here for the existential quantifier, we need to find just one value in my domain that makes my proposition return a value of true. So I've stuck it here actually in the loop. Anytime that this thing returns a true, I go ahead and just say the existential quantifier is true. So I keep track of all of that stuff. I loop over all the different values of my domain. I go ahead, I run it, I print it out, and there we go. We can find the truth values of these quantifier propositions right here with this propositional logic, and I can see whether or not these things are true or not simply by writing a simple program right here. Now, of course, this is only going to be helpful if your domain is finite, because if your domain was infinite, then of course this thing is never going to halt. But oftentimes you're considering domains that can be finite. So for example, we saw previously when we were looking at an entire subnet, so a range of different IP values, you can determine the truth value of these quantifier statements simply by looping over every value and keeping track.